Tune into this week's On .NET, where I have my good friend Mike on talking about .NET Monitor, an easy way to access diagnostic information in a .NET process. So tune in. Hey everyone, I'm James Montemagno, and we're back with another On .NET, this time talking about .NET Monitor. Have you been looking to get access to diagnostic information about your .NET applications? Well, today I'm going to show you how, because I have my good friend Mike on. Before I bring on Mike, don't forget to like and subscribe wherever you're at. So without further ado, Mike, how's it going?
Hey James, good to see you.
Good to see you as well. I cannot wait to talk about this because little did I know, Mike, that literally there's like 1,000 different diagnostic tools that .NET developers could use. Do we not know about this? What is going on here? There's so many amazing tools.
They have not been documented well up until recently, and we're continuing to produce more all the time. If you just go out and search on our docs for like .NET CLI diagnostics tools, there's like a whole suite of them now, and a lot of people aren't familiar with them.
Yeah, there's counters, coverage, dump, GC dump, trace, stack, symbol, SOS, DS router, and actually the one that we're going to talk about is .NET Monitor.
Yes.
So one, what is .NET Monitor?
Okay, so .NET Monitor is a little bit different than all those other ones. All those other ones are .NET CLI SDK tools that allow you to go and get some type of diagnostic information. Like you got .NET counters to view your event counters in real time or to log them. You've got .NET dump to collect dumps. You've got .NET trace to get performance traces. .NET Monitor is all about exposing those same types of diagnostic information, but over an easy to use HTTP set of endpoints. So the idea is, if you're like on your dev machine and you need to like get a dump, then like you just, you install .NET dump, you run it, you're good to go. But there are situations where you may need to diagnose stuff in some sort of staging or production environment, and you don't want to have to like connect the machine, install the tool, do all that stuff. Or maybe it's in like a containerized environment where that even becomes more complicated. And so by using .NET Monitor, you can have .NET Monitor set up either on the server or in a sidecar container alongside your containerized applications. And then it will have these endpoints that you can hit to get all of the same sort of diagnostic information you could get with those other tools. So it doesn't add any new diagnostics, but it provides an easy to use interface for getting access to them in situations where maybe you're not able to as easily connect to the machine and install all that stuff.
Got it. So many of the tools that we outline, the counters, GC dump trace, those are really like, hey, I'm developing locally right here and I'm doing some perf diagnostics, where Monitor is a monitoring tool, hence it's in the name, and talks about those more complex scenarios of not only running on your local machine, but you said like through maybe Docker or containerization or something called sidecar. What is a sidecar? What do you mean by that?
Yeah, okay, good question. I should have explained that better. So when you run in like Azure Kubernetes service or really any sort of Docker environment, you'll have containers, and containers as a best practice, you only have a single process in them. So your container is going to have like your production app that runs when the container starts and nothing else runs there. The idea of a sidecar container is a secondary container that runs alongside a primary container, usually shares some amount of state, like maybe a shared volume or process space, and is able to then interact with that primary container without cluttering the primary container itself with extra stuff.
Okay, it's like a little companion. It's kind of like, like the little motorcycles that have that little sidecar, I guess you'd call it. That's what it is. Got it.
That's where we get the name.
Okay. You're there, you're hanging out, you're cruising along, you're high-fiving on your cruise, but then you're also getting all of this information from your .NET application. That's the goal.
Yeah, that's the idea.
Awesome. Well, I'm ready to see it because I know that this thing seems super powerful from reading the documentation, and I understand you got a demo for us, Mike.
Yeah, I'm just going to walk through how we use it. So yeah, we can go ahead and share my screen and I'll show how it works. Now, I've done a few of these on .NET shows over the past number of months where I've walked through different tools like .NET dump, .NET trace, and I've always had like some sort of just little, contrived sample that breaks in some way. And then we use those tools to figure out what's going on. So I'm doing the same thing today. Okay. So I have deployed a small ASP.NET Core app into Azure Kubernetes service. And so I'm just going to hit the endpoint, show you that it's up and working. What happens when I hit this run task async is in my app, I've got a couple of account objects that I created that are supposed to be like, money in some account. And when I hit this endpoint, I provide a value, and it just moves some money back and forth in these imaginary accounts to say, oh, let's move $10 from account A to account B, and then maybe we'll refund it back from B back to A or something.
Okay,
so that's what's happening here.
And then it also rounds off like the 0.00001 penny, puts that into another account.
That's right. That goes in the super secret account, like the super secret one we don't talk about. Yeah, exactly. But it's a really small app. I coded up in like 10 minutes, but it's going to help us demonstrate a problem that customers may actually run into when they're using .NET 6 that you can diagnose with these tools. Cool. So that all worked fine. What's going to happen, though, that's more problematic is when I take that same endpoint, but I'm going to use this Siege command line tool to hit it with 15 concurrent users for 30 seconds just over and over again. So we apply a little bit of user load. What we're going to find here, I'll go ahead and run. This can take 30 seconds to run. When this comes back, we're going to discover that really it did not process very many requests because there's a bug in my application where it sometimes deadlocks, where sometimes when it's doing these operations, we get into a state where everything just sort of hangs and we stop returning requests. So we'll let this finish up so we can see that that's what happened. We should be.
And is this Siege tool? I understand what it's doing. It's sieging. It's like kind of like going. Yeah. You're telling it to do all these requests and simulating mass stuff. Is that a tool from us? Or is it a third-party tool? What is it?
It's a third-party tool. I just went out on the internet and did a Bing search for like command line load tool, and it was one of the first results.
I'll find it. I'll link it down in the show notes.
Yeah, it's just an easy way for me to hit this endpoint a bunch of times for demo purposes.
Cool.
Okay, so this one actually. Oh, we actually got 0 hits. Okay, so I must have deadlocked this thing like immediately. Usually I get like 6 returns before it hits it. But in this case, we ran for 30 seconds. Nothing was happening. If we go back to our curl command, previously this returned, in a matter of milliseconds. Now it's going to sit here forever. So our app's busted. We need to figure out what's going on. And this is a little bit harder than normal to investigate because it's hosted in AKS, in Azure Kubernetes Service. So I can't just trivially attach the debugger from my machine and see what's happening. So in the past, we've investigated issues like this by using kube control to exec into the pods and containers in my deployed app and actually installing things like .NET Dump. But this time, we're going to use .NET Monitor instead as maybe a simpler way to solve that same problem.
Okay.
So .NET Monitor can run 2 different ways. You can download it as an exe that just runs on your machine and exposes some endpoints that you can hit with HTTP requests, or we publish it as a ready-to-go Docker container that you can just deploy directly and have it be ready to go.
Wow. Okay.
Yeah.
So if you're already using containers, doing things like this, it's already set up and
super easy.
Yeah. Awesome.
Yeah, so if I take a look at my Kubernetes manifest, it's a real basic manifest. I've got my pod here. And I've got a container for my test app, which is just, pulling my app out of, Docker Hub. But then I've got a second container, if I scroll down, which I called sidecar. Okay, so we've got 2 different containers here. The first one is, what I would normally have in this pod. But this pod has a second container in it called sidecar, which is installing a container from this Microsoft Container Registry link, which is going to get the latest build of .NET Monitor for use with .NET 6. So there's a few other things that I configured here I want to point out. In my container, I do have an extra volume mount that I maybe wouldn't have otherwise had.
Okay.
Because .NET Monitor needs access to the temp directory in order to pull all of its information. So I've actually created a volume that I called Diagnostics, and I mounted the temp directory in my apps container to Diagnostics, and then in my sidecar container, I've also mounted the temp directory to that same volume. So they're sharing a volume. Then I've also specified here what arguments I'm starting with. So I'm just going to use kind of the default port for the APIs. And for demo purposes, I'm using the no auth, which means that anyone who has access to this port can make a web request and query diagnostic information. Makes the demo quicker and easier. In a real world application, you wouldn't use this. You would have authentication enabled so that in order to hit this endpoint, you need to provide a cert proving your identity, which is, obviously there's an information disclosure threat, as well as denial of service threats if you let just anyone hit these endpoints, because when you capture a dump from the process, it does pause the process for a short time to take that dump. So you don't want some random person there just capturing dumps all over the place and your app stuttering like crazy.
Yeah. So you might have this as in an admin portal that your developers go into, they're logged in, they're authed, and then there's a display for the information.
Right. Yeah, that'd be a good way to use it. I mean, and this is sort of a defense in depth thing, because this port isn't going to be published outside of my Kubernetes cluster, but no reason to make it easier on someone if they find a way to hit it.
Totally.
So then the other item that I have here, we'll talk about this one more later, is I've also mounted a config file. This is optional, but there's a number of things that you can sort of configure about the way the dotnet-monitor runs to kind of customize it. So you can mount those config files also. And I'm going to get into this one in about 5 minutes. I'll come back to that. But for now, the important part is that I've got my existing app just as it would be in my Kubernetes manifest, except that I've also shared the temp folder, and then I've added a second container in the pod that has access to that temp folder and uses this dotnet-monitor image.
Cool.
So with that, we can actually now start hitting this endpoint to start understanding what's going on with our app. So I'm going to come out here and do a control get pods, figure out what my pod name is so I can connect to it. Because the thing that I need to do here is, remember, I need to hit that 52323 port, which is not published. So I'm actually going to use kube control port forward, which allows me to forward a port on my local dev machine into the Kubernetes cluster.
Got it.
So
now you're using a lot of, as you kind of write this out, you're using a lot of, containers and the sidecar and things like this. But this also apply if like you would just have a, web app deployed to app service, for example?
So now app service is an interesting case, because app service being platform as a service solution, you don't need to worry as much about the individual things that are running there. So you typically wouldn't deploy dotnet-monitor in that case, but we're actually using features of dotnet-monitor under the hood to expose all of these same diagnostic things through the Azure portal page for your app service instance. You can go in there directly and get things like dumps and traces without having to worry about it. So that's actually kind of a different case.
Gotcha.
Where you'd use dotnet-monitor would be, I'm going through the Kubernetes thing because I think this is probably the most compelling use case. But you also, if you just have a server either on-prem or stood up in Azure, you could very easily just run dotnet-monitor as a standalone process rather than containerizing it. And then it's the same thing. It's like, okay, well, just make sure that you've got access to port 52323 or whichever port you set up, and you hit it that way. So it's the same thing.
Got it. That makes sense. Okay, those are good use cases and scenarios for it. Awesome.
Yeah.
Cool.
So, all right. So now my local port's mapped out to the Kubernetes cluster. So we can just hit this. Let's go out to that endpoint, and we'll start with the processes endpoint. This is a super simple one, just to show how it works. What this does is it returns information about the managed processes that dotnet-monitor is aware of that it can monitor. So I get back, there's a single process with process ID 1. Its name is .NET, and this all makes sense. This is what you would expect in a Kubernetes deployment. Now, is default is true means that that the tool has decided that this is probably the most interesting process. So when I make other requests, if I don't specify a process ID or a process name, it's going to default to this one, which is great. So that saves me a little typing.
Nice.
And we actually have some documentation. If you go out to the dotnet-monitor GitHub page, which is at github.com/.net/dotnet-monitor. First of all, the tool is entirely open source. You can file issues, pull requests, get involved here. But if you're just getting started, you'll want to look for the documentation folder, because in here there's explanation of the different endpoints that are exposed. So you can sort of understand the range of things you can do with the tool. So if we scroll down, here are the API endpoints. So I already showed processes. And then the rest of these, they're kind of self-explanatory, but you can click on them to learn more. But these are a lot of those same pieces of functionality that you got with the more targeted CLI tools like .NET Dump or .NET Trace. Here, there's a dump endpoint. There's a trace endpoint.
Okay. Kind of cool, because it kind of like brings a lot of those pieces that we were talking about earlier together in a live running application, in this case, inside of containers and Kubernetes.
Exactly. Yes,
Very
that's
cool.
the idea. So for this one, in this particular use case, I've got a hung application. I almost certainly just want to grab a dump and see what the threads are up to. But I do want to also show the live metrics endpoint, because this is kind of your .NET Monitor equivalent of like .NET counters. So it lets you get sort of a live feed of event counter information that you otherwise would have gotten with like .NET counters if you were live on the box. Now it's a little bit messy output because it gives you a bunch of JSON back, but I've used this before as a way to sort of just get a high level overview of what's happening if it's not clear what the problem is. This will give you like process like CPU usage. It'll give you heap sizes for the GC heaps. It'll give you thread pool health information. So it's if you don't know what's going on in your app, it's a good place to start. You can go out to let's see, it would be live metrics, and then optionally you can specify how long you want to stream this data for. I'll just say like 20 seconds. I think by default it's like 30 or 60 seconds, or you could say -1 for duration to just keep streaming. I mean, if you're going to stream a lot, you may want to have some sort of tools to pull out interesting stuff out of the JSON. But if you just want to get a snapshot of, hey, let me just look for the past 10 seconds, like what's happening with the CPU, how much memory am I using, how many thread pool threads do I have, what GC stuff's happening, this will dump it out. Now, this is a bit messy with my font huge like this, but if it was smaller, we could zoom out, it would be a little more readable. But the point is, you can sort of see in here, if I highlight like one of these, this is one instance of an event counter reporting in. So this is coming from the ASP.NET Core provider. It's the number of failed requests, and there's 0, okay? Here is the number of current requests in ASP.NET Core, and it's 16. Like, okay, already this is a little suspicious. Like, I haven't done anything with my app in like 10 minutes. Why are there 16 current requests?
Yeah.
But you can go up and you get all the same stuff that you get out of .NET counters, you get here. So you get like, large object heap size, Gen 2 size, percent time spent in the GC, and just all the usual stuff. So it's a bit of a kind of messy output for humans, but it's a good snapshot to start with.
I like JSON because you can do anything with it at that point.
You can do whatever you want with it. Exactly.
Cool. Nice.
Yeah. So I think that's a good endpoint to start with. Now, like I said, in this case, a dump makes sense because I don't really need like over time information. I just need to know, well, what's happening right now that's causing my threads to be inactive. We could look in here and discover that CPU usage is at 0. Let's see if I can find that in all of this text real quick, but if not, you can take my word for it. Here we go. CPU usage, %0. So that does narrow it down a little bit, that this is some sort of deadlock, not some sort of, hey, we're just spinning, adding integers forever or something like that. It's actually stuck doing nothing. So given that, I want to get a dump. So if we come back over to our documentation, you've got the dump endpoint. So it's as easy as making an HTTP request. And by default, if we look at these options that we can pass as query parameters, by default, it's just going to return to me the dump, which could be large. So they've got this really cool option called Egress Providers. And this is something that was added after the sort of initial previews of .NET Monitor. So if anyone kind of tried .NET Monitor as soon as it was released as an experimental tool, you might not know about this part. It's a feature where you can configure .NET Monitor with plugins that will actually send output data to customizable locations rather than just returning them in the response stream.
Oh, interesting.
So if you're doing things like collecting traces or dumps or whatever, you can say, hey, rather than just sending me this, gigabyte dump in the HTTP response, which, maybe that's not going to be as good. You can have it sent, for example, to like blob storage or something.
Oh, wow.
So I'm actually going to use this. I mentioned earlier that when I configured, when I set up my Kubernetes manifest, I mapped a config file for .NET Monitor. And this is the reason I did that. If we look at my config file, what we've got in here is I have an egress section in the config file where I'm configuring the Azure Blob Storage egress provider, telling it that I would like, when you write a dump, send it out to Azure Blob Storage, don't return it over HTTP. So you provide like the account URI, you provide your key and whatever else you need. And now when I ask for a dump, it's just going to write it here and I can get it from there, whatever's convenient. I can download it in a more reliable way and so on.
Yeah, and you could like configure it to run every so often, X, Y, Z, and then you're not going to clutter out this huge thing. You have it all in blob storage with timestamps. Very cool.
Yes, and in fact, that's actually something that I don't have in today's demo. But you can also set up triggers in .NET Monitor. So it will automatically collect dumps or other diagnostic artifacts for you under certain conditions, like, hey, after this long, or when this counter gets to this, amount. Like, there's like different triggers you can configure, and
Cool.
if you want to get more advanced with the usage, and then this sort of stuff is super useful.
That's awesome. Cool.
So, all right, so let's test it out. So we're going to curl out to the dump endpoint, and I do need to specify the egress provider I want. So the egress provider is going to be demo storage provider, because that's what I called it in my config file here.
Got it.
And then this really is all I really need. You also can specify dump type if you want. You can choose either a full dump, a mini dump with heap information, or a triage dump, which is even smaller than a mini dump and really just has call stacks. I always like full dumps, but the default is mini dump with heaps, which is practically the same. You're only missing image information. But just to show that this is an option, here you go. Oftentimes the default's fine.
Yeah.
But anyhow, I'll go ahead and run this. Comes back immediately with a 202 because it's not giving me the dump. But what it gives me here is this location. And this is an endpoint that I can hit to see the status of this operation, because in some cases, if you have a very large heap, you have a lot going on in your process, it might take a few seconds or more to capture that whole dump. So we can hit this endpoint to sort of see how that's coming along.
Oh, cool. Nice.
Now, in this case, my process is very small. It's super easy. So the status is succeeded. We probably grabbed this dump like almost instantaneously. And it tells me that this is the resource location. Like, okay, so we wrote a dump out to, this blob storage container under, a container called .NET Monitor, under a folder artifacts, and it's core 202. It's got the timestamp here for when I captured it. So if we come out to my blob storage account, previously there were no files in this, no blobs in this container, but I refresh it. All right, we've created our artifacts folder, and voila, here is the dump. And it's not very large, just 200 megs or so, because this was a simple process. But now this is available for me to debug.
Oh, very cool. Yeah, that's really neat. I mean, just being able to hit an endpoint whenever you need a dump and it just automatically goes into a location. I mean, that's pretty magic. I know you're like, oh, no big deal, but like kind of magic.
Yeah, absolutely. And super useful. So, at this point, then we can download this and figure out what's going on. So that I don't have to kill the stream with downloading 200 megs. I've already downloaded this earlier. So we've got core whatever here that, I captured like an hour ago. So let's just quickly wrap this up by diving in and seeing why we are deadlocking. So for this, I will use .NET dump. Although I also want to make sure that I've got all of my symbols available. So we'll start by doing like a kube control copy so that I can copy my apps symbols out of the container. You can also just get your apps PDB from like wherever it is. But all right, let's see, here's our pod name. So we're going to copy, let's see, from there. I know that this, oops, do that right. Yes, okay, so we're going to copy. I know that I've deployed my app into the app folder, DB, copy it locally, and this is in the test app container. It's good to specify the -c here since there are now multiple containers in this pod. I've got both the app and the sidecar. I'll also grab the DLL because that can be useful for debugging. If I can type right.
And this is cool because this gets into that scenario, right, where you're spending some time at this point. You're trying to figure out what's going wrong with your application. So now we're getting everything we need to do that, basically.
Exactly. And the other thing I will do is, because this is captured on a Linux machine, I may not have like the DAC and DBI that I need for debugging. So to make sure I've got everything I need, I'm going to use the .NET symbol tool, which can take a dump file as input, and we'll go out and with the debugging parameters, going to pull down all the necessary debugging files for that dump. With host only, it's going to pull down the .NET host, which is useful. So I run this, it's going to download a few things. Okay, and you can ignore the errors, those are expected. So all right, so now if I do a dir, I've got my dump file, I've also got my host and DAC and DBI, as well as the symbols for my app. So now it's as easy as .NET dump analyze on this. All right, we're in here. It's a hang, so I can start by seeing what the threads are doing. -all is a new-ish parameter for CLR stack that allows you to dump all managed stacks. So that can be useful. In the interest of time, I won't go through all of this, but I will point out that there's a number of thread pool threads sitting here waiting for semaphores, which is suspicious.
Very
semaphores,
suspicious.
Very suspicious. Now, we don't get like full call stacks here because these are called asynchronously, so that's makes this a little bit trickier. If this had been sort of synchronous calls, just like locking something, this gets super easy just looking here. You could even, if it's literally just a monitor, you can use the sync block command in .NET Dump to get a summary of all of the monitors and what's holding what, and it'll tell you this thread's holding it, this thread's waiting on it, and like you're done. So you know what the problem is. In this case, I made it a little more complicated because I'm using Semaphore Slim and I'm doing asynchronous waits. So it's not quite as obvious looking at the call stacks, except that there's something going on with semaphores. So another new command that people might not know about when you're using .NET Dump Analyze that I wanted to show off is you can do dump async. And this actually walks through the GC heaps looking for async state machines to try and reconstruct for you async call chains that are waiting. So I'm going to have it show me stacks for tasks. And this is going to dump out as best as it can from, reassembling things off the heap, the async stacks for tasks that are waiting. And so, okay, so here we've got like a bunch of tasks. As I go up and start looking at these, there's a lot to look through, but the pattern that I'm going to start to notice, you can already sort of just see as I'm scrolling through them, they all look the same. I've got some controllers that call into these action methods, come into my worker controller, and worker controller is calling transfer async, and now I'm getting stuck. Now, it's not quite as good as like the sync block solution for synchronous scenarios. We can actually see this thread's blocking, this thread's waiting, but you very quickly start to notice this pattern where, hey, all of these tasks are waiting for worker controller transfer async. I think it's stuck. So then, that's usually enough. You can jump into the code, come over into worker controller, look at transfer async, and we say, okay, transfer async is it's acquiring this semaphore for some source account. It's deducting a balance from the source account. It's acquiring a semaphore for a destination account. It's adding the balance to the destination account, and then it's releasing the semaphores. And you can start to recognize as you're looking at those threads and look at the way that this is being called, like, hey, wait a minute. What if the source account and destination account are swapped on two simultaneous calls? You may end up blocking the first one on account A, the other one blocks here on account B, and then they both come in here and try to get this second semaphore for the other ones. They both sit there forever, and now my app does nothing. And so you can sort of start to puzzle this out with that information. So that's the demo. Not a lot of time spent analyzing, but the thing I really wanted to highlight here was just how useful .NET Monitor can be for collecting all of these other sorts of diagnostic artifacts like traces, dumps, event counter information, in a situation where maybe you don't want to be, logging into the machine, installing a bunch of tools. You can just have .NET Monitor running alongside it and then make these HTTP requests to get that information.
Yeah, it's super cool. One, it's super awesome to see them in action. And of course, what I'll do is I'll go back and I'll find all the other previous episodes you're on talking about the other diagnostic tools and there as well. And then also, if we can, grab some of the sample code, we'll link it all up there as well. Mike, this has been really awesome.
All right. Yeah. Awesome.
Yeah. And of course, I will link to all the documentation because some of this stuff is super complex, but as you kind of saw, there's only a few lines of code, but then great documentation. If you have any questions at all, leave it in the comments below. Mike is going to be just on it every single day, looking for new questions and comments to answer them for you. So awesome. Mike, thank you again for coming on and showing this all off. I absolutely love it. To really help make your applications even better and diagnose those problems.
Yep. My pleasure, James. Thanks for having me.
Awesome. Well, thanks everyone for tuning in to this week's On .NET episode. As always, we're here every single week for you. Now, wherever you're at, go ahead and make sure you hit that like button if you're over there on YouTube. Hit that subscribe button as well so you get notified every single time we have a live stream or a new video comes out. So until next time, I'm James Montemagno, and this has been On .NET.